So the last topic we have for this term, outside of the hybrids, is transactions. Hang on, let me go hit the light. I love the 10-second delay from pressing a button to lights turning off. It's amazing technology we have here. Okay, is transactions. Now transactions is, I think these are actually my slides. So that's good. I skimmed them really quick. I've been fighting with something at my day job and I haven't had a lot of free time outside of it. So a transaction is a unit of work that changes the state of a database. Now, when you want to think about a transaction, it's literally a sequential series of steps that must all complete to be considered successful. The example I use in the real world for everybody in here is one you will all understand. You're laying in bed, your alarm just went off, you're getting out of bed. Successful getting out of bed means you are standing. I don't care if you're awake or not, but you are standing and the alarm has been turned off. There's a lot of steps. People don't realize just how many steps there are from going horizontal, no matter what posture you sleep in, to actually standing with an alarm turned off. There's, probably 30 to 40 different steps when you think about it. The thing is, to be successful, all those steps must succeed. Database servers have the ability to enforce those steps so they're treated as a single unit of work. And at the end, if it succeeds, it's called being committed. In other words, it's being written to the disk, or it's being rolled back, which is the closest thing to an undo you will ever have in a database. So, in other words, when all the changes are executed successfully, the transaction is said to be committed. Well, technically, it's ready to be committed, and then you issue a commit command, but it's committed at that point. And if we undo all the changes, because we never issued the commit command, we did a command called rollback instead, that means we undo everything. Most transactions involve insert, update, and delete. On MySQL, it will only involve insert, update, and delete. On other servers, it may include truncate and a few other istr commands. Okay, so MySQL, as being MySQL, is a little special. So MySQL transactions will end explicitly when they hit either commit or rollback. Other database servers, depending on which settings they have turned on, and most of them have these turned on by default, is a transaction rolls back on the first error. If you get an error, the whole thing rolls back. MySQL, it gets to the error and goes, I'll leave the rest behind. So unless you're actually watching for failed steps, you may actually commit a failed transaction. Transactions will end implicitly when they encounter a DDL statement. Again, you issue a bunch of insert, updates, and deletes. Suddenly, you do a create table. It will actually just try to run it. They'll try to commit your changes before it does the DDL. There's open bench over there. If you're looking for something, there's like that, or some up there, and there's room. All right, so the characteristics of a transaction. There are 4 characteristics, and there's an acronym called ACID. And A stands for atomic. It actually stands for another word also, which is atomicity. But I get a 1 in 5 tries of actually pronouncing it right, so I'm really glad we're going with atomic. I can't pronounce that word if I actually think about it before I say it. So atomic refers to that every command or statement in the work unit must perform successfully. In other words, every command must complete successfully. Going back to my example of getting out of bed successfully, you're laying on the edge of your bed, you go to swing your legs off, and instead of landing on your feet, you go and you just face plant because, you're hungover from the day before. Splat on the ground, transaction failed because, well, you're not standing, you're now in a all new state. That is a step that would cause a transaction to fail or the work unit to fail. Therefore, it's not considered to be an atomic transaction at that point because part of it didn't work. So it means it's all or nothing. Everything must work. If anything fails, everything must roll back. That's a pretty straightforward concept. Um, Consistent. It means that, why this? Yeah, okay, they're in the right order at least. Um, Consistent. The characteristic means that the state of the database is modified when the transaction succeeds, and only when it succeeds. It avoids damage from crashes, it avoids damage from bad code, it avoids all kinds of things. The example that we often use for this is banking. So picture you have two bank accounts. One has $500 in it, the other one has $0 in it. Easy concept to grasp so far. You're going to transfer $500 from one account to the other account. Now, in most banking systems, what it will do is it takes two commands, right? You're going to add 500 to one and take 500 out of the other. Whether you take the money out first and then add the money, or add the money and then take the money out, it's irrelevant. Different banks do it differently, but essentially the steps are the same. You start a transaction, you transfer the money, you complete the transaction. To be non-consistent, that would mean that you start with bank account one, $500. You put $500 in account two, and then the transaction fails, but then suddenly you're left with $500 in two accounts at the same time. That's a consistency issue because the database did not stay consistent to what it was before and after. Isolation. This is the one a lot of people have a hard time with. It's it's the magic sauce of a transaction. So essentially, it means that every operation within the group or unit of work is operated on independently from whatever else is happening in the database. So picture that you start a transaction, so you issue a begin command or start transaction command, depending what database engine you're on. And suddenly you're popped into a bubble universe with a copy of the database. You make all your changes. And while all these changes are happening, the rest of the database server does not see what's actually happening. As far as it's concerned, nothing is going on. You either roll back, which destroys the bubble universe, or you commit, which suddenly takes the changes from the bubble universe and applies it to the database. And durability. This one's easy to understand. Once the changes are written to disk, they stay written to disk. That's what that means. In other words, when things are committed, they're written to the disk. They will survive a server crash at this point because they've been written to the disk. Yeah, that's pretty much it. Durability means it's permanent. So there is a couple different commands. There's start transaction, which is synonymous to begin. You'll see me using begin everywhere. Why? That's because that's what it is in almost everything else, except for Oracle. Oracle is start because, but Oracle also supports begin. So, um, as you can see below, there's also some synonyms. A start transaction can also be begin or begin work. Some database servers will support all three because they're just nice guys. They're just synonyms. So, one command is, they just call the other command. Commit is used everywhere. That means that the transaction succeeded completely. Now we can write it to the disk. Life is good. Everybody else can see your changes, which at that point, commit basically implies durability because it's permanent at that point. Okay, rollback. Rollback is used to roll back a current transaction. Okay, that's, as I said earlier, we're going to roll it back. Literally, the command is rollback. So you get halfway through, you discover something is wrong, issue a rollback command, and things are good again. MySQL has a special command called set auto commit. By default, MySQL is auto commit on. In other words, if you type in insert into customers and some information, you hit go, and you never issued a begin command, it is now in auto commit mode, as in it'll treat it as a single step transaction and write it to the database immediately. Oracle, by default, is auto commit off. You actually have to tell it to commit any changes you write unless you turn commit auto commit on. So you got to go the other way around. So beware, depending what environment you're working on in the future, the behavior may be different from one server to the next. Um, so if you want to disable auto commit, you can go set auto commit equal to off, and magically your commit is now off. And there's one last thing, which is a save point. And a save point could be one of those things where you could actually have transactions that can be partially executed successfully and still be considered good. Um, so, for example, transfer money from one account to the other. So, take the money from account one, put it in account two, or I should say, add $500 to account two, take out $500 out of account one. Good. There might be a third step, which is add a log notice. Depending on the industry, that might be considered mandatory for the transaction, or it might be considered, an optional step of the transaction. So what save points will allow you to do is you can define a save point in the transaction, and if something goes wrong, you can go back, you can say roll back save point one or roll back save point two, and it'll just roll back part of the transaction, so then you can commit what did work. So I'll be completely honest, in 26 years of working in the industry, I've never used save points. That being said, I've never worked for a bank. I've never worked for the CRA. Call tracking systems in call centers. There's not a lot of steps between, type in some notes, hit save, and, update the ticket. So most of the transactions I've dealt with are 2 or 3 steps, and that is it. So save points are cool. They're good to have. It's like when you're playing video games and it has an autosave feature where, you reach a certain checkpoint in the game and then you die, and then you die, and then you die. Not talk about Dark Souls because that's not how that works. Because you just die in that game if you're not good. Um, but what happens every time you die, you'll go back to the checkpoint. So in theory, you could reach a save point, get past it, discover something's wrong, roll it back, and then you could theoretically try to redo those steps again. Maybe just something went weird or you needed to give some other data. It's kind of cool. So it's roll back to save point and you give it the number you need. You can release a save point. So that means that when you issue release save point, it removes the save point from the current transaction without changing the effects. That means that you've reached a certain point. You create save point one, do some more transactions, create a save point two. In theory, you could remove save point one so that you can't roll back to it anymore because everything is good. So you can basically create your own checkpoints in your transaction as needed. Like I said, not commonly used, but probably used very much in the financials and probably in a lot of government type databases, because they probably move a lot more stuff around than I ever did. So after you do a save point, you lose your ability to roll back. So you can roll back to a save point, or you can release a save point. At that point, you lose the ability to roll back to them, obviously. So save point, syntax of save point, name of save point. You can go roll back to, and you give it a name. Most people use numbers, save point one, save point two, save point three, because, it's easy. And release save points, the same idea. Okay, so that is all about transactions. I am now going to demo, which is why I dragged a chair up here because I need to sit while I do this. Sorry, guys, you won't be able to see me over there. Okay. And I need to lower this camera a bit. I bet you my video is going to be crooked as heck now. Oh, yeah, there it goes. Please stay put. Yay. Okay. So, get rid of PowerPoint. Bring this up. And we are going to be up. So I have a little database called Transaction Demo. In Transaction Demo, I have one table. It's, tons of info in that one. Put that down. There we go. I can see over here now. Now, MySQL has one other magic little quirk. which really, really sucks. If you do not use the right engine for the table, transactions do not work. 2 weeks ago when I tried to do this demo in my other class, it just never worked. And it took me a minute to realize when I created the table, I gave it the wrong engine type. So you need to use an engine type called NODB. This is a MySQL specific thing. Every other database engine supports transactions out of the box on everything in the database, unless you tell it otherwise, because that's the smart way to do things. MySQL, well, is not that smart. All right, so my trans demo table has two columns, ID and name. I am going to establish a second connection. So you notice I've got two connections now to the same database. I will go to it. First thing I'm going to do is I'm going to insert into trans demo name values Bob. So far, this is the kind of stuff you guys have experienced. You start the transaction, you hit run, and I have no feedback. It ran. So if I go in my second instance, and I don't know where I'm typing, but not in the right place. Here's Bob. I didn't actually run a transaction. This is what they call the implicit transaction or the auto commit. You issue an insert command, it automatically commits. Now, instead of that, what I'm going to do is I'm going to issue the begin command. And you'll see at the bottom, it says 0 rows affected. Fantastic. The other thing you will notice is this little dialogue sort of, the auto commit thing kind of highlighted all of a sudden because the auto commit's been turned off. Now I'm going to insert Frank. I'm going to run this one, and this is where I'm going to find out if I'm talking out of my back end or not. Trans demo. So here you see two rows. I'll go to my other connection, and you see one row. Even though we're talking to the same table at the same time. This is the isolation part of the transaction. This allows me to add records to my heart's content, modify the records. I could rename Frank. For example, I'll go update trans demo set name equal to Franklin, because the person doesn't like having their name shortened, where ID is equal to 2. Select star from trans demo, semicolon, grab the whole thing, run it. And as usual, it's just running the one command. Franklin's been renamed. If I come back over here, still not there. Now I come back to my first tab, and I'm going to hit commit. It just, magic happened. Now I rerun here. Here's Franklin. Franklin never shows up. Frank never shows up because Frank was being played with in an isolated room. So changes needed to be done. It's taken out there. Stuff is happening to it. Once it's committed, it's good. It's a bit like when you go to, let's talk about the lineup for the register of financial aid. There, that's a good one. So you're in lineup for financial aid, and whenever they call your number, you get to do all your stuff. While that's happening, nobody else knows what's going on while you're talking to the financial aid officer until they commit the changes to whatever system, Genesis or Access or OSAP or whatever they're typing in. Once they've done that, your transaction is now public because it's been made part of the system. Not public in the sense that, the other students can see what happened. It's public in the sense that it's been committed to the system. So I'm going to go back over here. I'm going to begin another transaction. And I'm going to go, actually, I'm going to do these one at a time because it's being really special today. Insert into trans demo name values. Put in Jenny. And if I go, oops, like star from trans demo. Again, this is nothing new. This is something you just watched me do a minute ago, just to prove that yes, we are in a transaction state. Now what I'm going to do, I'm going to say, oh shoot, we weren't supposed to add Jenny. I'm going to go roll back. Again, doesn't look like anything magic happened. Nothing showing up here. But now what's really cool, if I go, Jenny is gone because I rolled back the transaction. Hey? Yeah, it's basically as close to Control Z as you will get in a database. Um, yeah, that is a transaction. That's all there is to it. It's really the concept. Some people have a hard time wrapping their brain about which um, what's the word I'm looking for? Which letter of the ACID acronym applies to what step? Um, be thankful you guys aren't testing on that. My other group is, and they've been trying to figure out what each letter means and when it actually happens. But it's fairly straightforward. ACID goes with begin. That is the A in ACID. Now, if I do an insert, so I'm going to put some comments here. Oops. I'm going to put some comments here. Everything here is now I for isolation. Now I'm going to do insert into trans new keyboard. It's really bad. Name, values, Frank, because So everything so far is in isolation. So even if I did, I decided to put in Frank 4 times, everything here is still isolation. Now we put in commit. This is oops, D for durability because it's being written to the disk. Now you'll notice the magic word that is missing is consistent, consistency. That's because consistency means why does it not let me put a comment as the very first line? Really, it's going to be that picky? Okay. Why does it think it's an error then? Anyways, C, things are consistent here. So the C means that things are consistent before and they're consistent after the transaction. Yes, they could have gone CAID, which is harder to pronounce than acid, which is why C's in the middle. It's just for pronunciation thing, pronounceability. So yeah, so this is um, the commit, and I will actually put down put the word rollback here, but I'm actually going to comment it out. Um, there you go. That, everybody, is transactions in a nutshell. It's not a topic that requires a ton of words. It's just a topic that requires a clear explanation of what's actually happening. If you would like, I can post this as a file on the announcement. I am going to go file, save as. desktop like such, and I will post it so you guys have it with the notes that go with it. Um, yeah, that literally is it. So that was the last topic for the term, folks. I told you this was going to be a very short lecture. All right, I've got 2 questions, and I noticed him first, so he's going first. It is similar to working with version control, yes, but no. So it is like version control where you make changes on your local machine, then either you commit your changes to the repo or you revert instead of rollback. Yes, in that sense, it's like version control, except you're operating on live data, not it's not like it's happening on your computer, and if your computer shits the bed, that's fine. This is happening in the server while everybody else is using it. So imagine that you're using Git, and 6 of you are using Git on the same computer in the same directory at the same time. And for some unknown reason, whatever you're doing does not affect what the other guys are doing until you commit your changes. Okay? Like to force it on? Oh, you mean for the okay? I'm not sure. There's 2. Yeah, I think you're asking 2 different questions at the same time. Are you asking about auto commit, or are you asking about being able to allow MySQL a MySQL table to support transactions? So there's 2 things. MySQL will support transactions regardless. It's just whether or not it will honor the transaction, and you use a specific table type for that. Which, when you create a table, there's like this extra little bit you can type in with engine InnoDB. It looks something like if I go alter the schema. No, that's not it. That's not alter schema. I want to alter table. You'll see over here that it shows engine InnoDB. Yes, it's really small. I can't make that piece of the screen that much bigger. Um, so when you create this table, actually, I wonder if I can do this. There we go. Let's ignore all of this. See that last bit? I can make that nice and fat. In MySQL, when you create a table, you have to include that little bit. Otherwise, it will not support transactions. And here's the other fun gotcha for MySQL. I love his laugh. So let's just say your database consists of InnoDB tables and what's called an MyISOM table. So MyISOM is used a lot because it's really, really fast. Why? It's like driving down the highway in a car that has no roof, no doors, no brakes, and it only accelerates. As long as you don't need to stop and or be careful or, watch what you're doing, hot damn, that's the one for you. Hit a bump in the road, you're dead. Again, MyISOM is the same thing. InnoDB is the other one that has, the doors, the window, the roof, the working brakes, an accelerator that actually lets you take your foot off of it. It allows you to, you know, merge properly, use your blinkies, everything you're supposed to do when you drive. That's what InnoDB does, but it doesn't go as fast. Why? Because it has to support all this extra stuff, like transactions and proper trigger handling and all this fun stuff. So as a default now, I know if you're using MariaDB, which is MySQL's, first cousin, it defaults to InnoDB. MySQL 8, to my understanding, will default to InnoDB unless you tell it otherwise. So, it's not a guarantee that's going to be a problem, but you might just want to be extra explicit because As with everything else in computers, you should never, ever, ever assume it's going to do what you think it needs to do. Because I spent 7 hours today debugging something that was not my fault because I assumed something yesterday. Next term. Next term, you will take Oracle, Microsoft SQL Server. MySQL is going to come back for a party because, that's why we decided to use MySQL so that you don't have to install yet another one. And everybody's absolute favorite, Access. Access, last I heard, unless they finally change their mind, there are 3 labs on Access. I shit you not. Last time I saw the labs, yes, I had one of my friends that proctored the labs and he couldn't believe that they were still using Access. Hey, it's latest version of Access, not Access 95 or Access 97 when it was at its peak of goodness. And modern Access is actually a lot better than old Access because it's not actually Access inside anymore. It's actually running on top of SQL Server Express. So next term is where the people's good laptops and people's shitty laptops are going to get separated out. Imagine running MySQL, a web server, Oracle, and Microsoft SQL Server on your computer at the same time. Because Oracle and Microsoft SQL Server do not like being told that they're not allowed to run at launch. So if you're running like a 10-year-old laptop with like 6 or 8 gigs of RAM, it might be an interesting term. It's doable. You're just not going to have fun. Not like you'd have fun to start with, but it is what it is. So yes, next term you will learn about the other engines. Is it going to go in super detail? No. Your third database course goes in excruciating detail about Oracle. Excruciating details. I had to cover the labs for half a term for that course. And I studied Oracle when I went to college, so it's a few years, 26 years. And there's stuff in there I had no idea what this stuff was. I literally, like, as soon as coming up to me, they go, "Can you help me with this?" I'm like, what I had is I had the answers. And I'm going, okay, go research these keywords for this. It's kind of embarrassing. I said, honestly, I haven't used Oracle in years, and this was a panic fill-in. They needed somebody to cover the course for the second half of the term. So this was a long time ago. That was before these split terms. It was like really urgent. So yeah, so that is the end of the term for the most part. Next week will be another short class. It will be recorded. It'll be a review. But you've already got most of the lowdown for the final exam. 50 questions, Scantron, take a pencil. And if you're going to bring an eraser, bring a really good eraser. Scantron really does not. I'll lead you into a magic trick that a lot of people don't know about Scantron. I didn't know this until I started scanning my own Scantron tests, because we can. Which explains why it takes so long. Okay, we all know about Scantron this, right? 3, 4, 5. Okay. By the way, this is not going to scan, right? This, fill it in. For all it's worth, I should have made my circle smaller. Okay, pretend it's fully filled in. Okay, fantastic. Scantron will pick that up. You go, oh shit, the answer was B. So you kind of erase it, and then you fill in B. Let's pretend B's my poor marker. Let's pretend B is fully filled in. Scantron reads left to right. Now this will do one of two things. It'll decide this is the right answer, or if you're lucky, it'll still read the whole line because it's going to go, that one looks a little sketchy. Let's see the rest of the line. So then what it'll do is it'll come back and give me a result for the student of, let's say this is question 30 for student A. It'll go student A, question 30, ambiguous answer. Because it doesn't know which one's the right one. So what I tell people to do, there's 2 ways you can do Scantron. You can, by the way, we'll have extra sheets. So, if you screw up, we'll have extra sheets. Is either A, put your marks in your circles lightly at first and then go back over the end and darken them in. Or B, answer everything on the piece of paper and then transcribe at the end. that is your choice how you want to take it on. You know, if you're like one of those speed Scantron people, which I have seen, didn't necessarily have the best grade, but didn't have the worst grade. I've seen people, you know, do the Scantron exam and not put it on the piece of paper. So the rule is, and it's actually written on the instructions of the exam, um, is circle your answers on the piece of paper and do it on the Scantron. So if we end up with something really ambiguous, because what we'll do is we'll scan the piece of paper and then it'll tell us, you know, this student is that. So we go digging through the blue sheets of Scantron to look for the one that's for that student. Then we'll look for the question, see what they did, and then we'll decide whether or not they should get the point. Just if you're going to erase, erase. The other important rule about Scantron is make sure you put your student number and your name. I don't have any Scantron sheets with me. Hang on. I wonder if I can. This looks right. Yeah, that's. Oh, hang on. There. And I want to. Oh, it's still shitty. Okay. Very blurry view of a Scantron sheet. Okay. Up there is where you put your name. Fill it in. Because I've had cases where I got my Scantron sheet came in. The person wrote their name here, wrote their student number in the appropriate place, but didn't do any of the bubbles. So what happened is I got that the Scantron machine completely rejected their test. So it went through like, you know, I put 120, 110 in, it goes really fast, like chop, 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 chop. And it comes out and it'll just, that test does not exist as far as it's concerned. So it ends up coming to the end where I take the Excel spreadsheet, I look at it and go, hey, look at that. This person didn't write the test today. So then, depending if I'm feeling generous, I will go dig through all the Scantron sheets and see if the person actually wrote the test, or I might not. Which is why we have the attendance sheet, because then we'll just check the attendance sheet and double check that way. So yeah, that's a really crappy Scantron picture. Is there a better one? Oh, there we go. And that's barely any better. But that does give you a good view. Now, the other catch is if there's not enough room to write your whole name. So if people that have exceptionally long names, please at least put in your last name or your first name. Because I know there's somebody, I don't know if it's in this group or my other group, that has a name that's like 38 characters long. There's no way it's going to fit on the Scantron sheet. Sorry. So either do your last name and your student number. Because there's a spot for your, yeah, there it is right here. It's this block right here, identification number. It's similar to this. Their sheets are slightly different than this, but that's roughly what it looks like. So yes, please make sure you fill in. We will check them, but when we suddenly get a rush of all our students, we don't check them as well as we should. When you know, it's when the first person gives a test, we'll go, oh, that's pretty good. Okay, you can go. Oh, that's pretty good. Then suddenly we got 10 people in line. We're like, yes, no. Every question has one and only one answer. And some of these questions have been around for a long, long time. Why? Because they're good questions that didn't need to be reinvented. Okay. All right, everybody, you are free to run. I will see you guys in lab next week for demos. Oh, yes, I still have 19 students who apparently have not been assigned to a group. Yes, there's 2 students looking for partners. The problem is they're in different sections, and that's a big problem. Because if they're in my section, LM cannot grade my students, and I cannot grade LM students. Because that's just how the rules are, right? So how would we grade the 2 things and whose demo is going to be valid? That's the problem. So yes, if you're not in a group yet, please give me a group. Hang on.